Hello, it's been a while since I made a video like this. I'm just coming back from Furpoc, which was a lot of fun. I do plan on making a con video for it, but it'll take a bit of time to get through all that footage. However, I do want to talk about Furpoc Freestyle, the freestyle battle tournament I ran during the con. I added a few new ideas, and I definitely think they're worth sharing. Let's start off with what other cons have done. Over the summer, I went to Anthrocon, Megaplex, Philadelphia, and participated in their own versions of a freestyle battle tournament. Each had their own slight differences. For the most part, these were solid events, but I do have my critiques for each. I have two main ideas that I want to improve with this type of event: making prelims an open event that's centered around battling, and using the results from prelims to generate a finals bracket. Let's start with talking about brackets. Even brackets are pretty much the standard for running these types of tournaments. All the cons that I mentioned used even brackets. An even bracket involves a power of 2 number of dancers, 4, 8, 16, 32, and so on. 8 dancers is the minimum, being only 3 rounds long, and 32 is the maximum to stay under a 2-hour time limit. I'm going to focus on a 16 dancer bracket. Looking at what Anthrocon and Philadelphia did, the brackets had structure. The dancers were placed randomly in the bracket, but everyone knew what their bracket path would be after that. This is pretty easy to implement and seen as fair. It's all based on luck of the draw. However, there is an issue of possibly having 2 highly skilled dancers facing off in the first round, and one of them getting knocked off early. It did happen at AC. There is one key thing to point out, and this applies to all structured brackets. If the schedule goes from top to bottom for each bracket, the upper part of the bracket gets a slight advantage over the lower part of the bracket because of rest time. For example, the winner at the top of the bracket gets to rest for 7 battles between rounds 1 and 2, while the winner at the bottom of the bracket gets to rest for only 3 battles. This is what the amount of rest time looks like compared to the bracket starting position. This is just something that we need to keep in mind moving forward. Looking at what Megaplex did, there is no bracket structure since all the battles were randomized. There's still the chance of having the top 2 dancers face in the first round, and that did happen at Megaplex, but also dancers get an inconsistent amount of rest time between battles. For example, I was one of the first battles in the first round, and the last battle in the second round. Can you say icing the kicker? Meanwhile, Jodeci was the last battle in the second round, but the first battle in the third round, which, bless her for still being able to compete with those shitty odds. Yeah, no, I'm just not a fan of hosting a tournament like this. Okay, let's start looking at what types of brackets you can have with seeding. March Madness is a good place to start since it's pretty familiar with a lot of people. This type of bracket has the high seeds versus low seeds in the first round. This is great for keeping your top 4 dancers spread out in the bracket, but it also means that less experienced dancers are forced to battle some of the best dancers in the first round, which is not something I really want to see happening. Also, bracket path difficulty doesn't correlate with seeding, and I'll explain more of that later. We could also do what the WNBA does with their playoffs, have reseeding after every round. The first round is the same with the 1 versus 16, 2 versus 15, and so on. But then the second round has the highest seed versus the lowest seed, the next highest seed versus next lowest seed, and so on until you have your 2 middle seeds battle. Obviously, this means that top dancers get the easiest bracket path and the most amount of rest time. However, there is a chance that some dancers will get an erratic amount of rest time between battles, and we still have the issue of having less experienced dancers being forced to always battle highly skilled dancers. I calculated bracket path difficulty for each seed by adding up the reciprocals of the highest possible seed for each path. For example, the 1 seed will meet the 16 in the first round, then the 8 in the second round, 4 in the semifinals, and the 2 in the finals. So that's 1/16 plus 1/8 plus 1/4 plus a half. This isn't a perfect way to quantify bracket path difficulty, but it still gives us a pretty good idea. As you can see with the reseeded tournament, bracket path difficulty always increases as you go to the lower seeds. A March Madness type of bracket, however, has a more interesting difficulty curve, with the 11 and 14 having the most difficult path. So let's talk about balanced brackets. We're still going to fill the bracket with the upper seeds all spread out. The pivot of the bracket is where the middle two seeds meet, in this case the 8 and the 9. The bracket is then balanced after the pivot, where the highest lower seed is paired with the highest upper seed. In this case, the 10 meets the 1, 11 meets the 2, and so on for the first round. Mid to low seeds now have a better chance of winning the first round compared to a March Madness type of bracket, and high seeds can't exactly underestimate their first round opponents, which makes the first round more interesting. The 6 through 10 seeds end up having a similar bracket path difficulty with a 1 pivot balanced bracket. There's also the option of having a 2 pivot balanced bracket. This bracket is balanced around the 8-9 pivot in the first round like before, but also the 4-5 pivot in the second round. Now the 4 through 6 seeds have a similar bracket path difficulty, and the 7 through 16 seeds also have a similar bracket path difficulty. This is what the bracket path difficulty looks like for a 1 pivot and 2 pivot balanced bracket compared to the March Madness type of bracket. Notice that the 1 pivot balance helps the middle seeds more, while the 2 pivot balance helps the lower seeds more. And this is what the rest time looks like for each seed with the different bracket structures. Again, this is just something to consider alongside bracket path difficulty when choosing a bracket structure. Okay, now let's talk about uneven brackets. Uneven brackets can host any number of dancers. For uneven brackets, prelims would be used to award buys instead of making cuts like with even brackets. This is great because it offers flexibility and positive reinforcement. For a 12 dancer bracket, 4 buys would be awarded to the top 4 dancers. This one follows the same logic as a March Madness type of bracket. The great thing is that the first round consists of battles between dancers of similar skill. This is a lot friendlier to newer dancers since they wouldn't be forced to face the more experienced dancers in the first round. Also, the 11, 10, and 9 dancer brackets look very similar to this, with buys being awarded to the 5, 6, and 7 seeds respectively. This is what it looks like when we apply the 1 pivot balance to a 12 dancer bracket, with the 4, 5, 6 seeds acting as the pivot. And this is what bracket path difficulty looks like for the 12 dancer bracket. The 13, 14, and 15 dancer brackets are each their own special cases. This is what a 13 dancer bracket would look like for both the March Madness style and 1 pivot balance bracket. This is what a 14 dancer bracket would look like. And this is what a 15 dancer bracket would look like. Seeded brackets are good, but we would need a different format for prelims. The method of judging a freestyle showcase on a 1 to 10 scale is not really appropriate since it's really subjective. So we need prelims that are focused on battling, since judging battles is a lot less subjective than judging a freestyle showcase. A Swiss system for prelims is an option, but it has a lot of flaws. It only considers wins and losses, it requires a lot of rounds, and it's not good at determining middle seeds. Pulling another idea from sports, we could use the Massey method. It's a math method that accounts for the scores and who's involved with each battle. It requires a lot less rounds than a Swiss system, and it's a lot less sensitive to bias. So here's what I call the Rovak routine for prelims. Each dancer gets 2 battles, and each division has a chain of battles. For example, Alpha battles Beta, then Beta battles Gamma, and so on until the last dancer in the division, Omega, battles Alpha. The only info that gets recorded is which 2 dancers battled and what the judges' votes were. The order the dancers go in does not matter as long as the chain does not break. Furpoc Freestyle took less than an hour and had 17 battles with 17 dancers split between 2 divisions. You can go watch the full thing here. The judges' votes are added up to get a dancer's total score. A dancer gets a +1 for every vote they receive, a -1 for every vote they lose, and a 0 for every tie vote. For example, 1 judge voted for Alpha, while 2 judges voted for Beta, so Alpha gets a -1, while Beta gets a +1. The score from a dancer's 2 battles are then added up to get their total score. Next step is setting up what I like to call the battle matrix, which holds all the information for who battled who. The dancers' names are labeled in the top and side of the matrix in the same order as the chain of battles. The diagonal elements are the number of battles each dancer was in, and the off-diagonal elements is the negative number of times the dancer in that row battled the dancer in that column. For my routine, all the diagonal elements are 2, and the off-diagonal elements that are adjacent to the diagonal are -1. Everything else is 0 except for the top right and bottom left entries, which are also -1. Now, if you don't know linear algebra, this next step may seem a bit wild. Just go with it. Pick any row in the battle matrix and fill all those entries with 1s, and then the corresponding row in the total score with a 0. This is just to make the system solvable. It really doesn't matter which row you choose because the result will just be the same. Trust me on this one. The last step is to invert the battle matrix and multiply that to the total score. Pretty much just leave this step to Excel to do. Please just leave it to Excel. I wrote the command right there for you just to copy and paste. The values that are calculated give the dancers ratings. The highest rating gets the number 1 seed, the second highest gets the number 2 seed, and so on until the lowest rating gets the lowest seed. And that's it. That's the routine. How many times do you get to do math where you have something with a name called the battle matrix? My routine has quite a few advantages over other formats for prelims. Again, it involves a more objective scoring method. It keeps the amount of time needed for prelims rather low. The order the dancers go in just doesn't matter at all. And interesting enough, dancers get a slight boost when battling tougher opponents in prelims. Now the question is, how accurate is hosting prelims like this? Well, I wrote a program that simulates prelims where dancers get a random skill level, they battle each other, they're given votes for each battle, and then rate it using the Massey method. I used 3 different metrics to measure how effective the routine is: average buy error, average elimination error, and average top buy error. I say having an average error of less than 2 in any of these categories is totally acceptable. There's always going to be some random external factors when you run prelims in the real world that prevent perfect ratings. This is what it looks like when plotting the number of dancers in a division against the average number of errors. The number of judges and number of battles each dancer gets are listed at the top of each graph. The dots on the graphs represent the averages, while the bars represent the standard deviation. All these averages were calculated with 1,000 prelim simulations. These 3 graphs compare the different voting systems that a judge can use. My judges for prelims actually used the 5-point judging system, where the double arrows were used when a judge felt like one dancer absolutely dominated a battle over the other. As you can see, the more options the judges have for voting yields a better outcome. Similar can be seen when comparing the voting systems to average elimination errors, and comparing voting systems to the average top buy errors. And unlike the Swiss system, yes, you can have tie votes with my routine. It's actually more accurate when you allow for tie votes. So now, let's look at what else can be done to improve the results for prelims. These 3 graphs show what happens when you increase the number of judges. There is some improvement with buy errors, but not by much. Here's comparing the number of judges with average elimination errors. Again, there is some improvement, but not a whole lot. And comparing the number of judges with top buy errors. Again, increasing the number of judges does improve the results, but not by much. Now this is what it looks like when each dancer gets more battles in prelims, as in each dancer gets to battle 2, 4, or 6 different opponents in prelims. There is a dramatic improvement with buy errors, as you can see. Similar can be said with elimination errors, and the number of top buy errors. The thing to keep in mind though is that doubling the amount of battles each dancer gets means prelims doubles the amount of time. I did have a plan for a round 2 with Furpoc Freestyle, but I decided against it because of time constraints. But of course, I was curious to see what the possible upper bound is for running prelims like this. I ran simulations with 5 judges each and 5-point voting, with different number of battles each dancer gets, and had the simulations go all the way up to 64 dancers in prelims. This is what elimination errors look like. 2 battles can handle up to 32 dancers, 4 battles can handle up to 51 dancers, and 6 battles can handle up to maybe 68 dancers. Similar can be seen with top buy errors. 2 battles can handle up to 32 dancers, 4 battles can handle up to 54 dancers, and 6 battles can handle past 64 dancers. The takeaway here is that my method for prelims is pretty reliable up to 32 dancers per division, while also keeping the amount of time for prelims rather low. It gives the ability to have seeded brackets, which prevents the issue of having 2 top dancers meeting in the first round for finals, and uneven brackets allow us to be flexible with accepting a wide range of dancers into the finals. This turns prelims into a low-stakes environment that gives all dancers experience with battling, and it would be in front of an audience as part of the event instead of being a hurdle to overcome. I think this is just a great thing for our community to have. Looking ahead, I will run Furpoc Freestyle again with this format alongside Eden, Rito, and Hawk. We aim to improve the event for next year, and there's definitely room for improvement there. I'm also going to let other people know in the dancer community about these ideas, this video being part of that. I want to see a continued growth and improvement of all of this, and also help others with hosting events just like this. I may also code up an app that would automatically handle all these calculations, since I know not everyone knows as much linear algebra as me. My name comes from linear algebra. I am a nerd. Added bonus, I did try to combine 7 to Smoke with the Massey method to see if that would work as a possible prelims format. Turns out it does not. My original method worked just fine, and 7 to Smoke is just not good for a prelims format at all. So yeah, that's pretty much everything I wanted to say. If you got any questions, feel free to ask down in the comments below. Thank you all for watching, and I'll see you at MFL.